Hello, I'm Sujal, and today I'll be going over all the work that I did in the creation of Phantom Pursuit. To start off, we have the player. So these first three blueprints are pair programmed by me and Nat, so we've both done parts and chunks of both all three of these blueprints, so I'll only be going over stuff that I worked on and maybe slightly touching upon anything she did if it is relevant to some of my stuff. So to start off with, one of the main parts of the game is throwing, which is throwing the flare. So this is something I had tried to do myself at first. Took me a long time to figure everything out. Turns out there was a node that did all the work I was trying to do by hand for me, called projectile path advanced. Because why would Unreal not already have that? But it made work a lot easier. So the node goes very simply. It makes sure that you're not reloading first of all, and it starts throwing. It basically, when you're throwing, it pauses the timer on how fast the flare is like running out of time or going out. So theoretically, you could throw forever and the flare wouldn't go down. Although we did this more so for the ease of use of a player. They don't want a flare running out while they're still trying to aim, getting used to everything. So it is just a quality of life feature. So what this big node does is it gets the relative mouse position in world space, which is right here. So it converts it from viewport to world space, and then it does a bunch of math based on its throw multiplier, which is just a magic number that we use, and throw power, which is how long the player has held the left click for to predict where the flare is going to go when throwing it. And then it does a bunch of throwing lines, which I'll be going over in a bit, which are just small actors that the player spawns of these throwing lines, and they have one purpose. They spawn, and after less than half a second, they destroy themselves. So this is to make sure every time the player moves, new throwing lines are being constantly made and old ones are immediately gone, so they can't just paint using all those throwing lines. But after all it's done, it just exits out of throwing mode, and yeah. Once, that's all what happens when you press left click, and once you let go, it basically says, okay, you've thrown it, and what it does is, using those same numbers from before, it spawns a flare, and what it will do is it just throws the flare, where it just sets its linear velocity based on those same exact math used up here, basically copy paste it down here to make sure the flare always follows the predicted path. Very quick and I'd say simple, but it's in concept it's very simple, and after you figure out the math it does seem very simple. You predict the path by crunching a bunch of numbers, and then you use those same numbers to basically tell the flare where to go. And here's where throw power is calculated, where it basically throw power is either decided on max of 2 seconds, where this is it, and every second you're holding it for, it just increases by get world delta seconds. So max time you can hold it for 2 seconds. After that, does nothing. But once you do get it up to 2 seconds, you can throw the flare and like freely aim it. Another thing that I had worked on is the pause menu. It should be green, but what it does is it waits for you to press exit, which is the escape key. Once you've pressed it, if you are reloading, it just exits out of that. We did this as another quality of life thing, as what we had gotten feedback for is a lot of times players felt the reload was like an inventory, and in most games you can exit your inventory by pressing escape. So back then the players were pressing escape to exit the inventory and accidentally just quitting the game. So just to fix that, I made a small branch where it just checks if you're reloading. If you are, it's just going to stop reloading, where it just exits out. And if you're not, it just creates the pause menu, puts it to the viewport, and it just pauses the game of all the good stuff. Stopping enemies, and that is some of the big stuff. Another small thing I added much later on was another quality of life thing, which is the jumping and falling. So here's just setting the states for the state machine and animations, but what happens here is coyote timing, which is you can still jump off of a platform when you're no longer in it for a very small period of time. So it basically on movement mode change, where the moment you start falling, it says can jump to true, and after a retriggerable delay, which means if it ever stops, it can be retriggered again, or it could basically reset the delay. It says can jump to false, and you can only jump if can jump is true. So it basically checks if you're falling and can jump, or if you're idle, walking, or all where normally jump stances, you can actually jump. This makes it much easier for the player, as a lot of another feedback we had is they didn't explicitly say it, but a lot of times we saw players just failing to traverse the platforms as they're not used to the mechanics. So this was another ease of use thing to make it less focused on the platforming and more focused on the puzzle side of the game. And that is most of what I had worked on for the player. And of course there were a few touch-ups left and right where anytime I was needed for help, I'd help, but that's most of all for the player. Now we go on to another big chunk of code, which is the monster. Again, the monster was pair programmed by me and Nat, so it was mostly us sitting at her computer doing all the work, bouncing ideas off of each other and seeing whatever could work. So here we have a bunch of variables for the monster that basically choose what the monster does, everything that it can do, where it can go. It has the particle system, has an attack range, which is for when it can attack the player if it gets too close, and there's also a light range, which is used for the cutscene. These are both sphere colliders. Very as usual. But just to begin play, we set the values for the monster, where we're just based on if it's the cutscene version or not. Because if it's the cutscene version, we don't really need to change much. But if it's not the cutscene version, we need to assign all the parameters of how fast it needs to move, how often the eyes need to spawn, how often the particles need to appear and die, how fast they need to move, all of that. And a lot of it is just magic numbers that we have here. And these are all variables that have been created in the Niagara system using right over here, and they're vectors, and most of them are floats. But after that, there's a small delay function that's called at the very end over here, and what it basically does is it moves the monsters to the very first spot it's supposed to be in the room, and it just looks for where the monster needs to go. The monster goes through this array of room locations, which is the pre-designated path the monster should be traveling. So it can only move from one of those array points to a different array point, and it checks which one's closest to the player. Then it sets the player index, which is the target it's going towards, and in move, which is called that once it's found the target, move is called hey. Now just move me to that place, and moves, and then it just checks: do I need to go backwards or do I need to go forwards in the array, just up or down? And yeah, that's mostly how moving works. For the attack collision, the monster just waits if the player collides with it, and as long as it's not the cutscene version, it's gonna collide with the player. It will do a timer because we wanted to make it event based instead of having a lot of stuff on event tick, which would lower performance. Do it event based, so if it ever triggers it, we do a line trace to see if it hit the player or not, and if it does hit the player, we clear the timer, we just respawn the player as the player has died, and if the line trace doesn't hit the player and something's in between them, it does nothing. And of course, once they leave the range, it just stops it, just clears using, it just stops doing the line traces. And what light range does is basically when it's during the cutscene, it'll just check if the flare has collided with the monster. If it has, to just trigger the cutscene. And here, this is Nat's code where she just puts the cutscene in there. Everything. I wish I knew what she did, but it's almost like magic. So now we're moving on to the game mode. And the game mode also has some very important roles, as expected. But what it does is it's gonna, first of all, what we wanted to do is set a respawn location, which is the very first place the player spawns, and that's because whenever the player dies, as shown in right over here, it casts to game mode and calls respawn to respawn the player. But if respawn is called, let's say, somehow before the player triggered the cutscene, it's going to try and respawn in a null value. So to stop that, we just assign a default value. Even though it shouldn't be possible for the player to die, unexpected things can happen. And just in case, as a failsafe, we do have it set at the very first place the player spawns. After that, you enter the first room. It goes through every single room in the game to find which one's level 1 or which is the very first room, and enters that room. Very quick, since LDTK brings in rooms on its own, the array of rooms is messed up, so the array gotten from get all actors of class is actually out of order in how the rooms are supposed to be. That's why we do have to check for if the level equals 0, which is supposed to be the very first room. This is some Nat stuff. The cutscene, the monster delay. So this is another part that I worked on, and what it would like to do, or what it does, is it's going to check that, oh, you want to spawn a monster. So what it's going to do is it's going to get all of the monsters in the level. It will check if any of them happen to be in the same room that you're trying to spawn this monster in, since each one has a current room variable. And once it sees that there already is one, it's not going to spawn one. But if it says, oh, there's no monsters in that room, it's going to go in, it's going to set the monsters variable spawn construction based on if the monster's supposed to spawn, and it's a cutscene, so which is level 5, that's our specific cutscene one. And this only happens if the monster is supposed to be spawning and the monster points are greater than 0. And that's to make sure that the monster isn't spawning in a place where it's not supposed to spawn in. Because if the monster isn't supposed to spawn in there, it's going to have just 0 for monster points. But yeah, it checks if it's a cutscene level. If it's a cutscene level, we have a very specific spot for the monster to spawn. We have a very specific room, and its spawn time is going to be 0 because it's supposed to be instantly there. But if it's not that, it's going to be based on the current room, how fast it's supposed to be, and if it's spawned the cutscene one, it's also supposed to be smaller compared to the actual one when it's chasing the player. And reset room found, since this is going to be called multiple times every time a new monster's tried to be spawned. And yeah, that's what I've done in the game mode. These are the throwing lines that I've already shown. They are just made to constantly be destroyed and respawned. So up next is the flare, which most of this is not stuff. I've just helped her bounce ideas off of me. We pair programmed, although we had some ideas beforehand that we had to scrap and redid everything, so most of it is her redoing it. And this is just some spare code. This is some of the unused code that we had before. So here is the main menu that I made. It does a very quick create widget attribute. This is just a player for the main menu since it's its own level. That's why it's just made to an anchor for the widget to be connected to. This is the actual widget. This is the main menu. There was a different one before in playtest number 1, but Annie made this beautiful screen that she put in all herself, and Takaya made this title and the buttons, and I just put them all together in here. And it does some very easy stuff on make sure the mouse is showing, and when you press start, it's open level, which is our main menu, which is the game level, and if you press quit, it quits. Very self-explanatory. These are the basically animations, like animation sources and everything that were made. A lot of these are stuff we did in our first side-scroller project in Studio, so that's where I got most of this from. Here is our character state machine, locomotion. As a joke, we called it unlocomotion, and because we just couldn't get it to work, and since then it just stuck. But here are all the states of how you can go from where. But I'll see the artists do this. But you can go from walk to basically almost anywhere. And throwing, there's certain ones where walking, throwing mode can only ever go to either idle or throwing, because you can cancel from throwing mode. Throwing can only ever go to idle. And these all have their own conditions of, for example, let me just, oh no, I think I lost myself. Here, yep. The character is falling, then it returns. So a cool thing we did was we had before a bunch of bools, but we decided to use an enum for the character states, which made our work a lot easier, where we just have to check the specific enum, and if that enum is true, do the thing, otherwise don't do the thing. Very quick, very simple, and just made our jobs 10 times easier. So next is the tutorial text. This is something as well that I had made recently. It's a very simple blueprint where I have this collider right over here and a text renderer. So what it does is when you collide with it, anything can collide with this. It just sets the text renderer's text to show, which is instance editable, so it can be put in any place in the level. You just have to change it, change the text, and I can show an example right over here. Oh, if I can select it. just select it from here. Tutorial text. Right here. You can just text show spacebar to jump, and the moment you collide with it, text appears and it just stays there. Because I thought maybe the player couldn't read it if it fades out too fast, so we thought, let's just leave it there for the player. And it stays there even if you enter back into the room. After that is the pause menu, which I also designed much later. It's fun designing this, where it lists all the controls, just in case the player forgets. The cancel throw button, which we don't really explain in the tutorial since usually you don't need to, but if you ever want to go further in and look at it, it's always there, just a nice to have. Got the resume button, main menu and quit, just your standards. So the resume undoes what pressing escape did in the player, where it's resetting, it's getting the pause menu, and it's removing from the parent. If just in case there's multiple, removes them all, and it resets timer. No longer game paused. Quit just quits game, and main menu just opens the main menu. So here is light platform. A lot of this work right here was actually June's doing. I made a very basic script, which was this, and some of this. Actually, I don't think maybe a bit of this was me, but June went in and added a bunch of stuff to fit how she was using it in LDTK. But the concept is very simple, and to explain it, I first have to explain lights. The interface that I made called uses light. It has two functions: lights on, light off. Very quick. And what happens is when a vent, when the light is turned on, which is done in BP Flare, if I can find BP Flare here. Yes. Yep. Where did it go? I think June might have changed something. But the main thing behind it is whenever lights on is called, it basically... Oh, sorry. Now I remember what happened. I was just having a brain fart there. So, right over puzzles, there is a BP light sensor. And what that does is it checks if a flare has interacted with it, which the flare has a collider on it that can collide with the light sensor. And it basically checks if the variable that it has, target, which is an array, so one light sensor can target multiple objects. It just checks, hey, on that target, call lights on, like, which is this function right here. So all it does is go to the target and say lights on. And here is some of June's work, where it just changes the sprites to indicate to the player the light is on. And same thing here, when it stops overlapping with the flare, where the collider has reached outside the flare is, the light sensor is, it just says lights off and changes sprites again. And then in here, each puzzle mechanic has its own blueprint, where it does moves up, which is just for the platforms that move up and down. It moves up when the light's on, or moves down when the light's off. That's how I used to have it, but now I changed it, where now it could either be already moving and stop when lights on is called or lights off is called, or it can do the inverse. So I did this to make it much more flexible for June to design the levels, as some platforms can stop by triggering the sensor and some can start moving. I do a similar thing in the wall, where it just, oh, this is a lot of June stuff, but my code's just tiny bit here, where if lights on, changes it to lit transparency, which just shows, am I transparent or am I not? How transparent am I? And material of, of basically how it's supposed to look, and it just changes the collision, if it's supposed to appear or not. And the same here, these are instance editable variables. For example, right over lit collision, unlit collision right here. This is an instance editable. That should be instance editable, unless June changed some of the stuff. But this is a variable that can be signed. Oh, sorry. This is stuff that comes in from LDTK. That's why it's not instance editable. But this is assigned when it's all brought in from LDTK, and it basically chooses what happens when the light's on, what happens when the light's off. They're just inverse of each other. This is a material I made for the font. I used a link, that forum post that Kyle Hadji sent me, which helped me create this font material for the text renderer that I use. In, where is the tutorial text, basically? Right here. Here in the text renderer, I use the Poor Richard font, and here's the font that I created using that forum post as well for everything. And here's the Niagara system that I briefly worked on to just have spawn the monster, have these particles, and all that good stuff. So overall, my job was to create some of the core mechanics that really get the game together, but a lot of my job also involved just going into other people's code just to help something or tweak some of the code. So most of my job revolved around debugging, taking ideas, as well as making the asset tracker. All of that, as I was accountable for documentation too. So yeah, sorry if it's been a bit all over the place. Some of this code I am coming back to after a month or two, because my philosophy is, if I'd like to code something to the best of my ability at the very start, so I just don't have to touch it after I'm done with it. And I think I stuck to that quite well, as I coded these light sensors, and BPI uses light all the way back in early March, maybe late February, and since then I just haven't used any of them. I haven't needed to tweak them all because they worked, and most of the tweaking was done by June, where she was just fixing stuff up with just the transparency and implementing all the LDTK stuff in here. But yeah, which I'm really thankful for, because she's just been really helpful in understanding all my code and tweaking it however she needs. But yeah, thanks a lot for watching, and have a great rest of your day.